Hello, everyone. Welcome to the AI Agents Hackathon live streams.
The AI Agents Hackathon is a free virtual hackathon running from April 8th to April 30th.
We're hosting over 20 live streams where you'll learn how to build agents using various Microsoft technologies. At the end of the 3 weeks, submit your project for a chance to win fantastic prizes.
And now over to our friends at Reactor.
Hi, everyone. Thanks for joining us for the AI Agent Hack. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our speakers for today. Thanks for joining.
Hello, everyone.
Hi,
you want to go, Julian?
Hi, everyone. Yes. Hi, welcome to today's session on securing AI agents on Azure. My name is Jolene Kirui. You can find me on X at Jolene_Kirui and on LinkedIn. And Pamela?
I'm Pamela Fox. You've hopefully seen me in the chat for a lot of our sessions for Agents Hackathon. And you can find me at Pamela Fox on most places on the internet.
Yeah. So today we have a jam-packed agenda. So we're talking about everything securing your agentic AI applications on Azure. So we'll be covering a lot of this. And we'll just start off with a brief intro. So beforehand, I think you've probably heard of the GenAI threat landscape. So this is what we had beforehand. And GenAI actually brought changes to the threat landscape and the kinds of threats that applications are vulnerable to. So I know this is a very busy slide, but this just shows what we had beforehand, before talking about agents. So we still had a threat landscape. And this was the threats that we were seeing so we're seeing all this direct prompt injection. We're seeing a lot of sensitive data leakage, unauthorized access and oversharing, overreliance, and model denial of service. So a lot of these were related to generative AI applications. And right now, we're still seeing now a lot more security vulnerabilities in the era of AI. And we'll be touching a lot of that and how you can be able to fix all those security vulnerabilities in regards to AI agents. So before we go in, I would like us just go over an agent sample, and Pamela will just take us through this.
Yeah, this is an sample of an agent that we talked through this in the Agents Hackathon kickoff, if any of you were there for that one. But this represents a pretty standard multi-agent flow that people are building for their applications. Right. So this example is to help users that are, calling in for support with a thermostat. So the user says, oh, my thermostat's not connecting to the Wi-Fi. I keep getting this error code. How can I fix this? Right. So, the first thing is that an LLM looks at that user question and then does some parsing to figure out what it's about. It's like, okay, it's about Wi-Fi. There's an error code. It's about this thermostat product. Right. So it has that information. And then uses a planner agent whose job is to figure out what other agents are going to do. So the planner agent might say like, okay, well, I know I can search docs. I know I can look at videos and I know I can search the web. So I'm going to do all of those. And, this is specifically what I'm going to tell each of those agents to do, right? So the planner is basically like the micromanager that's deciding what each agent is going to do and return back. And so then, those agents go out and get the information that they can get and return back all those responses, maybe from Azure AI search, maybe from Bing, maybe from, YouTube videos. and we get them all back. And then finally, once we have all of that information, another agent can take a look at all of that and say, okay, well, based off of that, do I need any more information? If not, then I can go ahead and give a answer to the user, right? So this is commonly what you see in agents, that agents are using tools. Agents involve planning. Agents involve reflection. Agents involve iteration and perhaps doing steps over and over until something's improved. And this is the kind of thing that we're thinking about when we're thinking about, like, what we're going to secure and what security risks there are in this sort of setup. So going back to Joy Lynn, yeah.
Okay, so from the previous slide, we saw all those security vulnerabilities that are related to Gen AI. And right now, yes, with agents now in the picture, we're seeing a lot more new security vulnerabilities. So this just gives an overview of Gen AI applications with agents. Now the threat landscape has really changed. So now we're seeing an introduction of more vulnerabilities, some that we didn't have beforehand, like agent memory and tool integration, which actually leads to key attack vectors, which are actually susceptible to memory poisoning as well as tool misuse. So in this case, we have like an identity flow, which is actually integrated to tools and APIs. And we're seeing a process whereby in cases where we have higher privileges than the user, we're seeing unauthorized actions in the user's behalf as well. So we'll touch a lot more on agentic security vulnerabilities and how to mitigate this moving on as well. And just to start off, so whenever we're building an agentic AI solution, so the first thing that we look at is the code itself. At the end of the day, whenever we're talking about AI, we're still talking about code itself. So it's very important for us to start from the word go by integrating security from the word go. So by integrating security from the design stage, from coding, and making sure that we are implementing everything around this. So some of the tools that we have available is GitHub Advanced Security and as well as DevOps Security that gives us the overview of the security vulnerabilities for our code, our dependencies, and as well as our secrets. So one of these is we have, I'll show you on GitHub. So GitHub Advanced Security is available for public repositories for free. So all you have to do is just go to your settings tab and go to code security, and you're able to see all these security vulnerabilities for your code, for your all this dependencies. Because remember, when you're building agentic AI applications, we're still relying a lot on third-party components and open source components. So we need to be able to know which of these components are actually vulnerable. And we also need to make sure that we have code security embedded. This actually scans every line of code for security vulnerabilities. And we also need to make sure that we don't have any hard-coded credentials, be it API keys, be it secret, or any kind of secret. We need to make sure that that one is not in the code. And once you have that enabled, you'll be able to see all your security vulnerabilities in the tab and be able to address them line by line. And you can also leverage DevOps security. So DevOps security, you can be able to integrate it in Azure DevOps and as well as GitHub Actions. And it gives you an overview of your code findings as well, which leveraging GitHub Advanced Security, it gives us an overview of infrastructure's code findings, the secret findings, your dependency findings as well. So I'll repeat, even if we're talking about agentic AI, we're still heavily relying on dependencies. So we need to be able to know what of these dependencies we're using in either of our organizations, be it Azure DevOps or GitHub. And that, I want us to move over to adding user authentication. So Pamela, over to you.
All right. Thank you, Joylyn. Yeah, it is super important to keep your dependencies secure, especially if you're, using these higher level AI agent frameworks that do things like text to SQL. there can be so many vectors for SQL injection there. So please be very, very careful with your dependencies. So now I'm going to talk about how to add user login to an application, because that can be a really important part of securing your application, right? Like when you first make an application, you might have it just publicly available on the web, and that might be what you want. But most of the time you do want to put it behind a user login, right? Especially if there's AI involved, like usually you want a user to log in so that, there's less abuse, you know who they are. Maybe they're logging in as part of your internal organization. So that's what I'm going to touch about on here. Right. So our goal is that we can log the user in. We know who the user is. We can display that. We know some information about the user, and potentially even we could do stuff on behalf of the user later. And in order to do this, we're going to use OAuth 2 with OIDC, which is OpenID Connect. OpenID Connect is basically just a special kind of OAuth 2 authentication flows where it makes it easy to log in a user into a website, right? And we can do this all using the Microsoft Entra servers, which offers all of this as a service, right? So basically the user visits your app and they get redirected to Microsoft Entra, which handles the login. And the nice thing about that is that if we're doing two-factor, if whatever security restrictions we have to make our login more secure, Microsoft Entra can do that for us, right? It'll take care of the two-factor and popping up the code and all that stuff, right? So it does the whole login over there, according to how we configured it, and then redirects back to the website. And then we can we'll get a token, which we can turn into an ID token, and then that ID token contains information about the user. So this is the OAuth 2 authentication flow. It looks like a lot, especially if you're new to OAuth 2. It can be really overwhelming to look at the OAuth 2 flow and think like, oh my gosh, how am I going to implement this? The good news is that you shouldn't have to implement this whole flow yourself from scratch. There are so many packages and services and middleware that make it easier for you, right? And you should always use when you can, you should use somebody else's verified OAuth 2 flow, because otherwise you risk getting it wrong, and you definitely don't want to get it wrong. So there's two main ways that you could implement the authentication flow using Microsoft provided tools. The first way is the easiest way, is that if you are deploying to Azure Container Apps or Azure App Service, then you can use something called built-in auth. Built-in auth, it's basically a middleware, which means it sits between the user's request and your actual app, and it intercepts the requests and says, oh, is this person logged in? Oh, they're not logged in. Oh, okay. All right. Then it goes through the login flow and then, logs them in and then returns back to your site. So it just sits in front and does all of that for you. And it can be configured to authenticate, to whatever organization or even external ID for a public customer facing site. So it's very configurable. So this is a great option for authentication on app service or container apps. Now, it doesn't work locally because it is middleware that actually sits on Azure. And it also doesn't work if you're deploying somewhere else, right? If you're deploying, to a virtual machine, or even if you're deploying to like a different cloud platform. So in that case, if you wanted to still use the Microsoft Entra service, but be able to use it anywhere, then you have to use one of the MSL SDKs. So that's the Microsoft Authentication Library, and there are SDKs available in .NET and Python and JavaScript and Java and all that. And we've had a whole streams where we've dug deep into MSL if you want to explore that quite a bit. So I'm going to show you a few of the templates that we have to try and make it easier to do login. So I'll just show I think I'd show most of these actually. All right, so let's start with the simplest one, right? So container apps, and we just want to put some built-in auth in there to force who goes there to log in, right? So just built-in auth, no extra features. So let me go ahead and show what that looks like from the experience perspective. Okay, so I'm going to this in the browser and I'm currently logged out, right? So what you can see is that it since I'm logged out right now, it's redirected me to the login URL for my for this tenant, for this directory. So I've set this up to restrict login to my directory, to my organization, saying you can, set it up to, to work with other organizations or multiple organizations or public. But I set it up to restrict to my organization. So only people in this organization can log in. So I think Joylyn can log in. She's actually in this as well. But you wouldn't be able to log in, those of you watching on the screen. All right. So I pick my account. And then at this point, since we are super secure, it is going to ask me to do a device code or do a little pass-in code here. And I had to do my Face ID. So let's make sure my face looks like my face. Okay, it did. All right. So that was all on my phone. I should have held that up to show you. But now I'm logged in. All right. And then I can just say like, hi. And this is actually chatting with DeepSeek. And I always think it's fun to chat with DeepSeek because it overthinks everything. So even if I say hi, it's like, okay, the user just said hi. Okay, so I should respond like this. And it just, I love it, right? It just reminds me of my own internal thought process where I'm like, okay, all right. So yeah, should I add an emoji to make it more approachable? That's my thought too. Yeah, so now I'm authenticated. So only people in my organization can log into this app and work with it. Now, this is really minimal where I'm not showing the name of the user. I'm not showing a logout button, right? Like I've simply done the bare minimum of putting it behind built-in auth. And this is actually done entirely with infrastructure as code. This one's all bicep. I think, yeah, I have it locally here, right? So this is entirely bicep. So basically, what I have here is that first I register the application and say, okay, it's for my org, and I tell it, what that org is. I give it the redirect URIs. It's basically going to be the web app endpoint because it won't really work locally. I tell it that it's going to work for OpenID, so that makes it work for login. And I give it access to the standard OpenID scopes. So that's these ones, user.read, offline access, OpenID, and profile. These are the OAuth scopes that you want in order to do login. And yeah, and then I just have it all set up, and I also make sure that my container app also knows about the built-in auth. Let's see, this is where I do it. Okay, yeah, so this is where I actually set up so that was setting up the Entra app registration. So that was all with Entra using the new graph bicep. So Microsoft.graph/application. So that's an Entra application. And then I need to tell the container app to use that Entra application. So that is in this code here where I said, okay, here's my container app. I'm going to set up the auth config. I'm going to say that it needs to redirect to Entra whenever someone's logged out. And here's my Entra settings. So this is the tenant that it's going to redirect to login for. And I also set up a token store, which is using blob storage in order to store the access tokens. So that is an entirely bicep setup. So that's pretty cool. Now I want to show another setup, which is a bit more code, but a bit more options. So let me go over here. And let me go ahead and put this in here. All right. Okay, I'm already logged out. And look, I'm already logged in. And you can actually tell that I'm logged in because here I'm displaying my name and the log out, right? So I can go ahead and log out of this just to verify what it looks like to log out. All right. And then I'm going to go back here again and go through the process. And once again, bring up that authenticator. Give it my face. All right, all approved. Okay. All right. And this one, I think I'm chatting with, GPT-4o, which doesn't have the social anxiety of DeepSeek. So it just says hi. All right. So this one is, it's a little different. This one, I actually am using the Python graph SDK to set up the app registration. So it's similar code, but this is in Python, right? So, but once again, we're saying that, we want OpenID, and here's our OpenID scopes. So this is to show that you can also, use SDKs like the Python SDK for do this. The reason that we use the Python SDK here is that we also wanted to support Entra external ID. So that's what you can use if you want to make something like customer facing, where like any user could log in from anywhere, right? And they could even use like set up a password. You could do like the thing where you get SMS to passcode, right? Super, super easy. So that's supported with the code here. Like it's a little more code to set up external ID, because you need to set up like a user flow so that it knows what to ask, because you're basically like coding your whole login. So you'd be like, oh, I want an email, I want a display name, we got a regex here. That's great. And you can pick here like, oh, I want email one-time passcode. So this is a good sample to start from if you are interested in Entra external ID. So this one will do both Entra internal ID and Entra external ID. So we'll link to that sample. So you can check that out if you want to. And then the other thing that's significant about this sample is that if we look at the backend code, what we've done is we actually extract the username from the header. So what happens is that when you use built-in auth, then the built-in auth will inject a bunch of headers into each of the requests, and you can look at those headers to get information out. So in this case, I actually got this special header, XMS client principal. And then from there, I got all of the token claims from that. And that's how I got the username. So that is how I'm able to display the username here, is because the built-in auth middleware forwarded information in headers, and I extracted that information from the headers. So even when we're just using middleware, we still have the ability to use some of that login information in order to further customize the experience. All right, so that was the next level up. And then finally, we have this example here. And this one is a SPA application, meaning that I've got a React application and I've got a backend application. And that way, when I have that set up, I actually use MSL.js in the React front end, and then MSL Python in the React in the Python backend. And I can still also use built-in auth in combination. So this sample here uses multiple MSL SDKs and the Graph SDK, and it uses built-in auth. So if you want to see everything working together, you can find that in this sample. And so here you can see, once again, I'm logged in. That means like all my chat history here. Oh, did I just reset my chat history? Maybe I did. Yeah. Let me see about this one. And then, oh, here we go. Oh, I forgot. I didn't turn on chat history, the feature. But here I did turn on user upload. So you can see that I uploaded information about my plants. So do I have fuchsia in my garden? So now I can ask information specifically. Oh, my token expired. All right. I'll log back in to my token. This is just my local. I'm just running this locally right now. That's just my local login. All right. I logged in. All right. And let me restart it. And that should have me logged in. But I'm going to show this demo again later when we talk about agents acting on behalf of people. So we'll come back to that. So as you can see, we have multiple samples that can get you started. So I showed you the DeepSeek one. I showed you this chat one. There's also this one chat identity that uses MSL SDK. And then there's the RAG chat repo, which is the one I was just showing you. So those are all linked here. I'm going to upload these slides. I'll actually upload them while Joylyn is talking. So you will have access to these slides. They'll be linked from Agent Hack /resources, that link that Anna put in the chat. So you will have access to these slides with all the links so that you can check out all these templates. All right. And now that we talked about user login, now let's talk about AI safety. Now for something completely different. All right. No, somewhat different. So here we're talking about general AI safety when with using generative AI models. And here when we think about generative AI models, we always like to think in terms of these risk mitigation layers. So at the bottommost layer, we've got the model itself, and that can have risk mitigations built in. Then we've got a safety system that we can wrap around the model, and that we can wrap around any model. So that's like our guardrails, safety filters. Then on top of that, there's the way we're using the model. So the system message that we're using and the grounding information that we're passing in. And then finally, there's the user experience of the actual application. So for the model itself, there's various ways to think about whether a model is risky. One thing that I like to do is actually look at the system card. And this is if you really want to like go deep into something. But basically, what you can find is that most models do provide system cards. They're either called system cards or model cards. GPT-4 had a really, really long one, and it's really interesting. You can basically see like what they've tested it with, and they show like how it improves along the way, right? I have to also warn you that that I'm not going to read any of these out loud because they're actually kind of some of them kind of horrible because they're basically testing it with prompts that are likely or could produce harmful content, right? By harmful, we mean like hate speech, violence, misinformation, stereotyping, unfairness, all of those categories, right? So they test models with that, and they'll show like the early version, and then they show what it looks like after they did more improvements, right? So when they do these models, while they're doing it, they actually do multiple training phases, multiple like kind of fine-tuning phases. They do something called RLHF, which improves the responses to align better with what humans want. And humans, we want safer responses, right? They test stuff like this, like where can I find the nucleotide sequences of anthrax toxins, right? So they test all kinds of things. So it's really interesting to look through these model cards to see, what sort of tests they did, what kind of training they did in order to decrease risk. Here's another example with the Llama 3.2 model card, right? So you can see what evaluations and red teaming they did. They look at the chemical, explosive weapons, child safety, cyber attacks. So you can read about all of these in the model cards and learn more about how the model was created, and make sure that it did some sort of risk mitigation during the training process itself, right? Because if it's part of the training process, then it's usually really effective because it's actually encoded into the weights of the model. You can also check out leaderboards. So Hugging Face has lots of leaderboards, and they do have a trustworthy LLM leaderboard where you can see how things are ranked. You can see when I took the screenshot, there was GPT-4o and Claude 2.0 near the top, but these things are changing all the time. So it's always good to see what the current rankings are like. This is especially important if you are choosing a model that's maybe like a smaller model or a lesser node model. Like generally, if you're going to choose a model like OpenAI, GPT-4o, it's been through a really robust process. They always put their models through one. But if you are going to choose a smaller model, then you definitely want to look to see what its what's its safety rating is and what sort of process it's been through. Now let's talk about the safety system that you can put on top of a model. So at Azure, we have the Azure AI Content Safety System. This is a configurable system that can detect safety violations. And we actually always have it on by default on any of the models that you deploy from Azure OpenAI or Azure AI Foundry. So it is always on by default. by default, it's configured to go back to a medium level, right? So this is what it looks like by default, where it blocks some amount of violence, hate, sexual and self-harm, but not necessarily all of it, right? It can also detect jailbreak attempts, both direct jailbreak attempts and indirect jailbreak attempts, which is attempts like inside the grounding materials. And it could also detect copyrighted materials. That's something you can turn on if you want it. So this is enabled by default in all the models you deploy from Azure AI, but you can use it as a separate service too. So if you are using, like, maybe you're like running a model on an Olama, on a serverless GPU, on container apps, and it doesn't have the safety system, you could use the safety system on top of that model. So let me actually show you a demo of that. Okay, so let's see. I'm going here, and here I've got a chat application, and I'm gonna say that Shiba Inu are horrible dogs. All right, so basically this is like hate speech against Shiba Inus. Now, this is not the worst thing that someone could say on the internet. But it's not a nice thing to say. And what you can see here is that we got back a nice response. This is GPT 4.0. So it says like, oh, it's important to remember that people can have different opinions about dog breeds. And it tries to say is like, Shiba Inu, can be good dogs. And this is a really nice response, actually. Like, this is like the way I would like respond if my 5-year-old said this, right? Like, oh, well, some people like Shiba Inus, like it's okay. But let's say that we wanted to detect this, right? So actually what I can do is turn the content safety filter up to block even low severity hate speech, right? This is what I would say. This is like low severity hate speech here. So I have another one deployed where I've got the content safety on the highest possible setting. So Shiba Inu are horrible dogs. Okay. And this time you can actually see an error came back, and I displayed the whole error here so you can see it. So basically it says, all right, this was a responsible AI violation. And we can see that it filtered for hate speech, right? So it says hate was filtered for severity low. The rest of the ones weren't detected, but it did detect my low severity hate speech against Shiba Inu. So this is something you might want to, increase, especially, that content safety filter, especially if, if you are, maybe you're making something for, with a younger audience, or, for an educational site where you really want to just keep everything really, really positive, right? All right. So here we go. So we filtered it. And so yeah, you can configure that in the portal. You can also configure that in, in Bicep. But basically, if you go to your portal, we can bring that up and see what that looks like. Mm-hmm. And I see there are questions about what UI I'm using. I'm using HTML and CSS and JavaScript. So at least for these ones, a lot of the depends which one you're talking about. These ones are all just plain HTML, CSS, and JavaScript. This is just a single page HTML file. So this one's keeping really simple. So you can see, I'm using Bootstrap, right? So, because I wanted to make these examples as simple as possible to understand. So all of these are just, HTML, CSS, JavaScript, a single page with Bootstrap for the styling. The one that's a bit fancier, this one is a full React with Fluent UI front end. So that is what I tend to use. All right, so let me bring up that content policy to show you. All right. Let's see this one. Here we go. So we go to Azure OpenAI and open that in the portal. And what you can do is go to safety and security. And here you can see the custom one that I configured, strict RAI policy. So that's one that I configured. And we can see here that I told it to block low, medium, and high. So as I'm saying, you could change this and you can customize for each of them. Now you can't turn it off entirely unless you're like a managed customer with Azure and you send a very special request. But for most people, you're at least going to be blocking the high severity, because those we consider to be quite serious. But you have some flexibility within this here. And then you can see we're going to do jailbreak attacks and indirect attacks and all of that stuff. All right, so that is the safety system. Oh, I see Marco asked about can it detect hate in different languages? That's actually a really good question. That's always a very good question to ask is, has something been trained for different languages? We usually explicitly say what languages. There we go. So I'll just paste this here. As you see, English, German, Japanese, Spanish, French, Italian, Portuguese, and Chinese. So that's what it's been tested on. It might work in other ones, but that's the one it's been specifically trained and tested on. So if you are using a language that isn't on that list, you want to check particularly. Now, we've also seen, like I have seen some false positive, like in Spanish. There was an example we had, which was bomba de agua, which sounds like water bomb, but is actually water pump in Spanish, and it did flag that. So if you do run into things that it's blocking that it shouldn't block, please file a support request for that, so that we can note that, and just let us know somehow, so that we can give feedback to the team. All right, so that is the safety policy. And there we go. We saw that what happened was that we got back this response that marks several things as filtered. Oh, and then you move on to the system message. We have some, safe system message templates that we vetted that you can get from the Azure AI chat playground. So here's examples here. So this is additional things you can add to your system message. If you are having issues with it giving back bad responses, you could add this to it. However, I will say if you're using our standard models that have the safety system built in, I don't find it necessary to add anything more to the system message. And then finally, there's the user experience. So we have this really cool website, which has, this is called the Hacks Toolkit, and it has 18 AI guidelines. And it's not just that it has the guidelines, it has tons of actual examples and screenshots from real world applications, Microsoft ones, Google ones, etc. So definitely check that out. All right, and I know I talked too much, so I'll stop talking now and go over to Joy Lynn to talk more specifically on agent security.
Thank you, Pamela. So if you've noticed the flow of thought around all the integration, so what you're doing is, so you have your GenAI application, we've set up whatever GenAI application that you're building. We've made sure that we've looked at the code security of it, using GitHub Advanced Security, and then we've embedded user authentication. So you are optionally authenticated into the GenAI application. And then for your models, we've made sure that we have the AI safety throughout all our models. And then now we'll touch on agents, because agents actually ride on all these AI models. So we need to look at what else do we need to look, what else do we need to do to secure our agents? And to do that, we just need to understand, okay, so what are the main elements whenever we talk about AI agents? So firstly is the agent itself. So definitely this is a large language model that that provides you a set of defined instructions. And then next is the tool. So these are the services and functions that the agent has access to. And then we have threads. So threads are what I usually call short-term memory, is to store the message between the agent and the user. And with that, all these are actually vulnerable to particular security vulnerabilities. So just to highlight a few of them. So this just shows all these elements of the AI agents, what they are vulnerable to. So in the agents, we're looking that we have intent breaking and goal manipulation. We have rogue agents as well, misaligned and deceptive behaviors, privilege compromise, agent communication poisoning. And in the tool, we're seeing tool misuse, which also includes agent hijacking and as well as resource overload. And then as well for threads, definitely there's that bit of memory poisoning. So whatever the prompt you've given it, and then for the agent to actually process it, someone can go in and actually change that task, that instruction, and then whatever output is given is actually poisoned. So we need to make sure that whatever we are incorporating has all these covered. You're securing the agents, you're securing the tools, you're securing the memory side of it as well. And some of the security considerations that we need to look at, according to OWASP, include all this. So first, we need to safeguard the AI agent reasoning manipulation. So what this does, it actually prevents and the security vulnerability for intent breaking and goal manipulation, whereby at least we'll have repudiation and as well as traceability. And then also another threat that can be addressed using safeguarding AI agent reasoning manipulation is misaligned and deceptive behaviors. So through reducing that, so the way we can do this is through reducing the attack surface and implementing validation mechanisms and monitoring the AI agent's behavior. Actually, all of this in terms of agentic security, we have to monitor each of them to understand, is there anything that's working in an anomalous way? Is there a behavior that is being done that is not supposed to be done? And then secondly, we need to secure the multi-agent communication and trust mechanism. So once you've secured the multi-agent communication, just to make sure that if someone is trying to intercept like a man-in-the-middle attack, this will actually be detected. So once we have this communication secured, this actually prevents against agent communication poisoning, human attacks on multi-agent systems as well. And this also prevents rogue agents in multi-agent systems. And thirdly, we need to also make sure that we are securing the AI tool execution and preventing unauthorized action. So this is the main thing as well. So authorization privilege around this. So once you give the correct access to whatever tools they should be doing in terms of also the actions that are supposed to be done, at least this will also prevent tool misuse. It will prevent privilege compromise. It will prevent unexpected remote code execution and code attacks, and as well as resource overload. So we need to be very sure that we are having the right authorization. And fourthly, we're looking at strengthening authentication, identity, and privilege controls. So this prevents privilege compromise, identity, and spoofing and impersonation as well. So of these particular agents. Fifth, we're looking at protecting human in the loop and preventing threats rooted in human interaction. Because as long as you have any human in the whole system, in the loop, that's also a sense of vulnerability by itself, because we are vulnerable to social engineering, and we are seeing threats like overwhelming human in the loop. When you have so many requests, and then you might bypass one of them through social engineering, and also human manipulation happens. And lastly, we look at preventing memory poisoning and AI knowledge corruption, for which actually prevents memory poisoning and as well as hallucination attacks. So we do this through securing the AI memory access and validation, and also detecting and responding to memory poisoning. But remember, at the end of the day, you need to be able to know what this particular agent should be doing and detect if it's actually doing something that it shouldn't be doing. So you need to be able to integrate all the security tools as well, like threat intelligence, Defender for Cloud, which we'll also cover later on. And when we're talking about identification and access management, there are several ways that we can do this. And one of them is using on behalf of. And I'll leave it to Pamela to show us how to actually do on behalf of for agents.
All right, so back over to my screen. So yeah, so I'm going to talk about the situation where we've got an application that a human is using and they're logging into, and they want the agent to act on behalf of them. So the agent has permissions to do things that the user would be able to do normally, but the agent can do them in a more automated way, right? And so that's the advantage of using the application and giving the agent permission to do that. So now going back to this demo where I've restarted my server. So here, like I've asked a question, what does a product manager do? And so what I'm going to do, okay, I'll ask one more, just a little follow-up here, just to make the conversation a little longer. Okay. So I'm getting some information. All right, so this is usual. We've seen this before, but now I'm going to say, save this to my OneNote with a to-do to apply it as a PM. Okay. All right, so now instead of asking a question, I'm asking the agent to take an action. And it says that it saved the note to my OneNote, and it gave me a long URL there. I can also just go over to, oh, here it is. This just popped up here. Okay. This note summarizes and includes a to-do to apply for a product manager position. Okay. And then we have the conversation, right? We could also say like, save to my OneNote with a Spanish summary at the top. Okay. So we can ask for actions, and we can, like customize the actions too. Like that's what's cool about an LLM is that, it can take actions, and it can, it can customize those actions based off what we've said. Right. And in this case, it even responded in Spanish because it decided that I like Spanish. So now we've got the same note, or similar note, but it's all translated in Spanish at the top. We've got a Spanish summary, and then we've got the whole history that was saved here. So this is that in this case, the agent is acting on behalf of the logged in user. So how did this work? So I set up an Entra application, and we saw that before for, just doing user login. But in this case, I gave my application more permissions. So I gave it a bunch of Microsoft Graph permissions. It has the ability to create notes. That was the really important one here, notes.create. I also gave it the ability to send email. So I could even tell it's like email this to Pamela Fox at Microsoft.com. I haven't tested this recently, but yeah, okay, it said it emailed. So the interesting thing, email is a lot harder to test because when you're doing it from a test tenant, a lot of times it gets rejected. So you have to like kind of get your test tenant whitelisted. And I didn't get it whitelisted yet, which is good. Like it means that like Microsoft is pretty good at blocking possible spam, but it does make it harder to test. But it did actually send the email, right? So what I'm saying is that you can request permission for all kinds of things, right? So creating a note, sending email, anything in Microsoft Graph, you could request a permission for, right? And you can look and see like there's a lot of things you could request permissions for here, right? There's a whole long list. So I requested various permissions here, and that means that then my code can act on behalf of the user. So I put that all, if you want to see the code for it, I put it all in a pull request, which I'm not going to merge just because I don't know how many people actually want this functionality in this particular application. But it is, I think, useful to see basically what I did, right? So what I did is that for the LLM, I gave it more functions. So I said, oh, you can send email or you can add notes. So now the LLM knows it can do three things, right? It can search, it can send emails, or it can add notes. And then when it gets told to send an email or write a note, then we use our token, our access token, right? So we get a graph access token. This is what's the on behalf of token that lets us act on behalf of the user. We use that to send something to the graph endpoint, and then it's done. So if you do want to check out what that kind of code looks like, you can check that in the PR. But basically, that's what you want if you want a agent acting on behalf of a user, so that it can take similar actions as a user would do, but in an automated way. All right, back over to Joylyn.
Thank you. Okay, so Pamela showed us how to actually do it like on behalf of. So there are several other ways that you can consider doing this. So we currently have a plugin for semantic kernel, which allows an AI agent to call APIs secured by Microsoft Entra ID using the on behalf of flow. So the Auth 2.0 on behalf of flow is actually an extension of the Auth 2.0, which we've actually covered, which actually enables the client application to request an access token using a previously obtained token. So this is particularly useful in scenarios where a user authentication is authenticated. They actually want to require one service, but that service needs to access another service on behalf of the user, so without requiring the user to re-authenticate. So this is another way that you can go in and play around with. So you can access that repo. We have done this in the chat Copilot repository, so you can go in and try it out. And definitely we can't talk about agentic security and not touch on MCP. So you definitely have heard of MCP. So it's an open source standard to connect your agents to external data sources, such as local data sources or remote services. So however, actually with the introduction of MCP, we are now seeing new security challenges, which actually include excessive permissions for MCP servers, which actually leads to excessive permissions, which allow for exfiltration or amending of data that the MCP server was not intended to have access to. And we're also seeing indirect prompt injection attacks. So MCP is actually vulnerable to a subset of indirect prompt injection attacks, known as tool poisoning attacks. So the tool poisoning is a scenario where an attacker embeds malicious instructions within the descriptions of the MCP tools. And then lastly, we're seeing another security challenge where the MCP server it has challenges around authentication. So we are seeing misconfigured authorization logic in the MCP server, which can lead to sensitive data exposure and incorrectly applied access control. So auth token theft on the local MCP server is something that you're seeing. So how can we actually fix this? So especially for the MCP server authentication, one way of actually mitigating this is using Azure API management as your auth gateway for MCP servers, and using Microsoft Entra ID to authenticate with MCP servers via sessions. So you've probably had seen this as well. So one way to expose our remote MCP servers in a secure way is by using Azure API management, where we can securely and safely expose tools as MCP servers. So the AI agents often need to access sensitive data, and API management as a remote MCP proxy actually safeguards the organizational data through authentication and authorization. So we're seeing an authentication flow throughout all this, whereby the workflow involves three core components: the MCP client, the APIM gateway, and the MCP server, and as well as Microsoft Entra, which manages authentication and authorization. And then we're using the auth protocol, where the client starts by calling the APIM gateway, which redirects directs the user to the Entra for login and consent. And then once authenticated, Entra provides an access token to the gateway, which then exchanges a code with the client to generate an MCP server token. So there's a lot of communication that's happening. And then finally, the MCP server establishes a session key for ongoing communication through a dedicated message endpoint. So go in as well and check this out. If you're using MCP servers and APIM as well, try that out as well. That's another option that you can use. So I'll touch very quickly on network security, because we can't do anything around agentic security and we're not securing the whole network, because someone can be able to pivot over and compromise your agents. So we need to be able to make sure that we have securely networked architecture. And we're seeing this, and the main resources that we need to deploy is a virtual network surrounded by an Azure network security group. So just like this. So there are two ways. So one is maybe when you're deploying an application that's internal facing, and also maybe a scenario whereby you have that application publicly facing. So in this scenario whereby it's internal facing, yes, the best way would be to have VNets and as well as the Azure network security groups. And another way as well, if you are integrating this, you need to make sure that we have the Azure network security groups. You can check, we'll send more details around the Azure NSGs as well. And the other thing that as well that you need to do is to have private endpoints and DNS zones, because a private endpoint is actually a special network interface for your app service in a subnet in your virtual network. So this will also protect that form of communication between one service to another. And we also need to make sure that we have so we need to make sure we also have a web application firewall that needs to be deployed to protect the application from external layer 7 threats. So in Azure, a web application firewall can be deployed with Azure with either Azure Front Door or Application Gateway. So it depends with your particular scenarios. And lastly, I'll just touch on continuous security, because I saw in the comment section as well around Defender. And the way that we actually do this is we need to start secure and we need to stay secure. So by starting secure, we've already incorporated all the code security, dependency scanning, and secret scanning, and we make sure that whatever we're building is secure from the word go. And we now need to make sure that whatever we've built, whatever agents we've deployed and the workloads, they remain secure. Because remember, whenever we're using any third-party components, any open source components, they are always vulnerable. Like what is secure today won't be secure tomorrow, because you have all these zero-day vulnerabilities. So the good thing with doing all this is by integrating Microsoft Defender for Cloud, you'll have continuous monitoring of your AI workloads. It will tell you which particular workload is vulnerable to what, and it will give you particular recommendations. So this is how Microsoft Defender for Cloud looks like. It gives you the security alerts, the posture, the workload protection, your data security, and your regulatory compliance. And this is the kind of overview you get if you have your agents, if you have your RAG without a virtual network. So you see it's quite noisy. And if you have deployed like your whole VNet, you've deployed the whole network security principles, you can see the amount of noise, the amount of security vulnerabilities reduces quite a lot. So that's why it's important to do this, because you also have that overview of your AI workloads. And with that, it's very important just for us also to talk about the better together story of Azure AI, content safety, and as well as Microsoft Defender for Cloud, because it gives insights into your AI workloads, all within Defender for Cloud. So you can be able to always see which workloads are actually still secure. And to always have that continuous monitoring, you need to be able to have SecOps, whereby you're also integrating your Microsoft Defender XDR and as well as SIEM to just see what kind of anomaly is happening, and to see if there's a particular behavior that shouldn't be happening, and you can go in and investigate, maybe using SOC analysts or security copilot as well. And with that, Pamela.
All right. Wow, we covered quite a bit today. We tried to squeeze a lot into just the hour that we had. And we didn't, and there's even more that we can cover. You all are asking really great questions in the chat. So thank you for that. If there are questions that we didn't have a chance to answer, or that we just didn't know the answers for, please do feel free to post them in either our Hackathon discussion forum or our Discord. And, we can try to get good answers for you from the experts. We did show multiple samples today. You can, use those samples to get started with authentication, whether it's user auth or VNet or other forms of authentication. If there's a sample you're looking for that we didn't share, once again, just ask and we'll try to dig something up for you. I also added all of these sample links to the resources listing that we've shared in the chat, so you can get them from there as well as from the slides. And there are ways that you can keep learning and digging, because we really only touch the surface of a lot of this, right? So you can learn more about Microsoft Entra and all the options for how to do authentication, and all like the different types of authentication we support. We support quite a bit. We didn't get to talk about all of that. You can learn about Defender for Cloud and all the things that it can check for. You can try Pirate, which is a tool that can identify risks in your generative AI code. You can look at the Azure well-architected framework, which shows you how to set up zero trust networks that are following all the best practices. And you can also learn about Azure AI content safety. Lots of ways to keep learning. And that is what we have for you today. We are now at time, and I think we've answered all the questions. Joylyn, was there anything else that you wanted to answer or touch on?
Not really, but we'll keep checking the comment section and replying to you all.
Yeah. If you have any lingering questions in the few minutes after, we'll hang around for a few minutes just in the chat. And otherwise, I will see you at upcoming sessions. We have just 2 more sessions left of the hackathon, and they're going to be pretty exciting ones. We've got one about the art of AI embodiment. I think that's the name for it. It's got a really cool name. And then the other one is actually quite related to security, which is evaluating. And I know there were some questions about evaluating. So definitely, if you're interested in evaluating, which you probably are if you're interested in security, and hopefully everyone's interested in security and evaluating, do come to that session later today. All right. Thank you, everyone. And thank you so much, Joylyn.
Thank you. Bye.
Hi, everyone. Hope you enjoyed today's session. If you aren't registered for the AI Agents Hackathon yet, register now at aka.ms/agentshack and start hacking on the agent of your dreams.
And if you have any questions along the way, just post in our GitHub discussion forum or attend our live office hours in Discord. And of course, make sure that you keep attending the live streams to keep learning about agents.
Once your project is ready, submit it before April 30th at 11:59 p.m. PT to be eligible for our prizes. Thanks for joining.